sketch the graphs of the following linear equations. Still linear equations, yeah? Now, what was chosen was y equals 2/3 x. Now, before I start off on this one, I want you to look at all 6 of the questions under this heading, okay? In fact, I'm just going to write all of them so that we can all compare them. You don't have to write them all down. But as well as this one, they have this, and this, and this.
So are we just revising or are we actually doing this chapter?
We're doing this chapter. Okay. All of these things, these are not revision, and they are covered under the same idea. Okay.
Oh, what is that?
Okay, now just have a look at these 6 graphs with me, or I should say,
So what is that?
Other answers, other questions.
if you were listening about 30 seconds ago, you would know.
No, I wasn't told.
Yes, I know. These are the 6 questions underneath question 3. Okay. Now I want you to look at them with me and try and work out, like, why are these grouped together? What do they all have in common?
Isn't it like
X.
Okay, they all do have an x in common, but you know what?
Isn't it the other way around?
These also have x's in common,
The what?
right? What is it about these 6 that are in common among these 6 but not in others? Yeah.
There's like times something in the other questions, and this one's just like one number with the A.
Aha. Okay, hold on. Let's just say that again, because that's really important, right? These numbers, so I should say these equations, they're all similar because it's just something times x, and then that's it. That's it. It's just like 2/3 times x, or 5 times x, or a half. Right, you get the idea. All these other ones, they've got extra numbers flying around. Okay. Now that actually means something. It means that all of these things are actually adding 0 on. Now, you're like, what's the big deal? Why even bother adding 0? Because it doesn't change it, right? Well, that's why it's not written. Okay. But think back to this first question we did here, right? There's this number out the front of the x. What's that mean again? It's gradient. Okay, so you got a whole bunch of gradients. Then you got the second number. What's the second number?
y-intercept?
It's the y-intercept. Now here it was -8, but over here, all 6 of them, the y-intercepts are all 0, right? So in fact, even though, you know, I'm cheating a little bit, you guys asked me to draw E, we can actually draw all 6 of these on the same graph. Watch, let's do it now. Let's draw up a set of axes. Make it reasonably bigger than the other ones because we're going to put 6 graphs on it, so it's going to get a little crowded. Okay. Now, the y-intercepts for all of these are all 0.
Should we
Okay.
draw that as well?
Sorry?
Should we draw that as well?
Yeah, draw up a set of axes. Okay. Now, if all of them have the same y-intercept, 0, that means they all pass through there.
Or reach it?
Every single one of them. Right? So they all intersect. The fancy word for this is they're all concurrent at that point. They all pass through. It's like a giant, crazy intersection. Okay. You thought that County Drive roundabout was bad. This is going to be a lot worse. Okay. So let's start with let's start with the one that you guys picked. So 2/3 x. Okay. Now, in order to draw this out, I want you to get a ruler out. Let's do this. Let's do this as accurately as we can. This number, you already told me, it was the gradient, right? Gradient is rise over run. Rise over run. So we're going to go up 2 units. So get your ruler out, right? And I want you to measure up 2 centimeters. 1, 2. So that's the rise. And then we're going to run 3 units. So I want you to measure 3 centimeters. 1, 2, 3. Okay. So there, that point there, that'll be 2 up, 3 across. Rise, run. And now you can join that guy up. That's fine. Okay. Let's label it. You'll see why in a second why labeling graphs is so ever important. Jacob, you're going to ask a question. Did you want to?
Ruler. That's right. I'm
You don't even need to, you just use a graph then.
Yeah, it does help though. So. I can tell throw. Sorry, it's too
Right
late.
now, bend your arms.
If only I can throw harder. All right, now there's the first one. Good, done. Okay, let's have a look at the next one. Y equals 2x. Right now that's really 2 over 1. So you got the rise and the run there still. Okay, so the rise is 2 and the run is 1. So you go up 1, 2, and then your run is 1. So now you're here. Okay, so I'm going to join up these 2 dots. Let's see how I go.
Wait, could you repeat that, sir?
Yes, I will. Okay, so what just happened? I went from this graph and I started to look at the next graph. Because this one, it's done.
Oh,
It's out of the way.
next graph.
Yeah.
Okay,
So
that
now look at this one. It still goes through the same y-intercept, but its gradient is 2. So it goes up 2 and across 1. Okay? So now this one's done. Okay, what about this one? Minus 3x. How do I graph that? It goes down, doesn't it? The rise is negative 3. So get your ruler out and go 1, 2, 3, but in the downward direction. And then the run is 1. Okay. So now this is the point I'm going to go through, and I can join these up. Right, this is a bit harder. Try this.
You're very messy.
I just got it, just barely. Okay, so this line I just drew starts the curve a little bit. That's minus 3x. Done? Okay.
Should we write plus 0 in the end of them or not?
No, that's okay. I did plus 0 to illustrate the fact that all of them have the same y-intercept. Okay, because it's not as obvious when it's not written there. 5x. Now, before I do this, before I put it on there, where would you expect 5x to be?
On the right.
Now, you know that it's going to be increasing up towards the right, so that's good. But you also know, for instance, just compare this one and this one. Right? You have 2x and you got 5x. Which one's steeper? 5x is steeper because 5 as a gradient is bigger than 2 as a gradient. So there's 2x, so it's going to be like this, but even steeper, right? So the gradient's 5, so you got 1, 2, 3, 4, 5, and then you go across 1. Right? That's really steep, isn't it?
Very steep.
So you try your best. You'll be fine with a ruler, I think. Okay, there you go. That's that steepest one I've got there. Y equals
So
5x.
why did we go across 1?
Because really that 5 is a 5 over 1. So rise over run.
So is it always 1 over?
Well, you have a look at the different numbers you've got.
No. Okay,
So-
say for the minus 3x, is it 1 over?
Yeah. You mean over 1.
Or over 1? Yeah. Oh, I'll still go like, yeah, 1%.
Alright, we're almost done. I'm going to do these a bit quicker because I think you're starting to get the idea. A half x, right? Rise is 1, run is 2, up 1, across 2. So it's going to be there, and I'm going to draw that across.
Wait, why'd you got 1 if it's half?
Because
The rise.
rise is 1 and
Oh.
run is 2.
Oh, so even if it's like y is 5, x is 5x over 1.
Yeah, that's right. That's right. And then my last one, minus 5 over 2. So rise is minus 5, minus 1, minus 2, minus 3, minus 4, minus 5. And then the run is 2. Let's see. This is a bit tricky. It should be.
Just beliefs.
It's very close to this one.
Yes, very, very.
Now, by the way, I don't know if you heard me say that. This one here I just drew, minus 5 over 2x. I knew that it was going to be very close to minus 3x. Can you see why? Minus 5 over 2, that's an improper fraction. What would you write it as a mixed numeral? Yeah.
It'll be 2.5.
Yeah, that's right. Minus 2.5. And of course, minus 2.5 is very close to minus 3. 2.5, 3, they're only off by a little bit. And that's why the lines are only off by a little bit. Okay? So now you can see all these lines, all 6 of them, they all pass through the origin because they all have the same y-intercept. What changes is the gradient.